So we were discussing about the address resolution protocol, ARP protocol. The acronym of address resolution protocol is ARP. So as we have seen, it's a network layer protocol which is used to find the physical address or the IP address. So there are two kinds of addresses: the logical addresses and physical addresses. So the physical address can be determined by using the ARP protocol. And as we have seen, that there are two parts of ARP protocol. The first one is called as ARP request. As here you can see, there's the ARP request, and then the second part is ARP reply. Basically, the internet is based on IP addresses, as we have seen, because unless the IP addresses are given, the machines cannot be identified on the internet, and the entire network cannot become functional. However, as I mentioned, that IP addresses they are of IP addresses they are logical, and the MAC addresses they are physical. So data link protocols like Ethernet, FTDI, or ATM, they may have different MAC addresses. So MAC addresses are the actual physical addresses. So here you can see, for example, if you are using Ethernet, then Ethernet MAC addresses could be 48-bit address, and IP address is 32-bit address. So these two protocols, the ARP and RARP, these two protocols, they take care of the translation between IP addresses and MAC layer addresses. And this ARP is basically very important as far as the local area networks are concerned. So Ethernet LANs, ARP is really, really important. And for just to understand this, there is a very good diagram I got it from internet. How the IP packets are processed by the network drivers. So network driver basically is something like Ethernet driver. So the how the IP packets are processing. We have seen that the entire datagram is converted into packets, chunks of data, and these chunks of data they are actually coming over the Ethernet, right? And then once the frame comes on the Ethernet, there is a demultiplexer, and the demultiplexer will be the input will be the datagram packet, and output will be the IP datagram, which is put on the IP input queue. Here it is a IP input queue. Now the IP input queue will be something like it will check whether it is a multicast or it is local IP address. In case it is local IP address, then ARP comes into the picture because basically the node or the host is on the same network where it is local IP address. If not, if not, then it's a multicast or broadcast kind of this scenario. And here you can see that IP destination, whether it is a multicast or broadcast, is seen. So if it is not multicast or broadcast, then the machine or the node is existing on the current network, on the local network, or it's a part of the local area network. So in that case, now you need to see the ARP packet, and you need to determine the ARP address. So from the ARP packet, the ARP address can be determined. So this is the overall functioning of the entire IP processing, because when IP packets are processed, then actually the IP packets are part of the local network or the internet. So both the things are seen here, and the processing is done on that particular basis. So we were discussing about the address translation with ARP protocol. So there are two machines which is shown in this particular network. There is a machine called as Argon, and there is a router basically. Now Argon broadcasts an ARP request to all the stations on the network. So what is the hardware address of the router? So Argon wants to know that what is the hardware address of the router. So Argon is having the IP address 128.143.137.144. So this is the IP address, and the MAC address is as indicated. While router 137 has got IP address 128.147.137.1, and below that the MAC address is given. So ARP request, because ARP, as we have seen, it has got two parts: the ARP request and ARP reply. So Argon will give ARP request, and this ARP request is sent to know the physical address of the router. So this will be broadcasted to the network, entire network. So all the machines, all the hosts will get this ARP request. And in turn, the here the request which is given going here, you can see here, part of the request is the IP address. The IP address corresponding to the router, and we need to determine Argon wants the MAC address of the router. So the IP address of the router is given here, and it will be sent on the entire network. However, the match is there only with the router. So when this match is found, then the router will respond with an ARP reply. So here it is ARP request, and here it is ARP reply. And that reply, in that reply, it will give this particular MAC address. So 00 E0 F9 23 A8 20. So the entire MAC address is given as the ARP reply. So this is how the address translation and ARP request and ARP reply works. And this is the entire format of ARP packet. So the packet here we have seen. This is the ARP packet, and this ARP packet has got the format which is shown on the slide. So it has got the Ethernet header, which consists of the destination address, the source address, and the type. And there is a padding and cyclic redundancy check to error detection and for error detection and error correction. And this particular part, the 28 bits, they are the part of ARP request or ARP reply. Either it can be ARP request or it can be ARP reply. This consists of hardware type, which is given 2 bytes. It is 28 bytes. So hardware type 2 bytes, protocol type 2 bytes, hardware address, the length is 1 byte, protocol address length is 1 byte, operation code is 2 bytes, and this is followed by the source hardware address, the source protocol address, the target hardware address, and the target protocol address. Uh, a noteworthy thing here is the length of the address fields. The address fields is determined by the corresponding address length fields. So it can be variable also. So here it is shown. The source hardware address is, but this particular is the source hardware address. Okay. The source protocol address is this. The target hardware address is this. The target protocol address is this. And this is the part of the ARP request from Argon. While the ARP reply, which is coming from router 137, this is the source hardware address, this is the source protocol address, this is the target hardware address and target protocol address. So in this particular manner, the entire ARP protocol works. Uh, so this is one thing about ARP protocol. The next one in this line is the ICMP protocol. The ICMP which is shown here. ICMP stands for Internet Control Message Protocol. I stands for Internet, C stands for Control, M stands for Message, P stands for Protocol. So this is a mechanism used by the hosts or routers to send notifications regarding the datagram problems back to the sender. We have seen that there could be a missing datagram or there could be some problem with the datagram. So there has to be some mechanism for the host or the router which is part of internet working, so that the problems can be reported back to the sender. And ICMP, the Internet Control Message Protocol, is a control mechanism which makes sure that these kind of problems can be addressed. Actually, the datagram travels from router to router until it reaches the destination. So in case the router is not able to route the data, maybe because of some unusual conditions. So these unusual conditions could be disabled link, or suppose a device in between is on fire or network congestion. So anything can happen. So in that case, there is a missing datagram, and this missing datagram is addressed by the ICMP protocol, Internet Control Message Protocol. Again, ICMP has got two parts: the ICMP test, which is used to test whether the destination is reachable or not. So basically, before sending the datagram, the every care should be taken, or one should make sure that whether the destination is reachable or not. Okay. So that particular care is taken by using ICMP test, which is a part of ICMP protocol. And when that destination is reachable, there is a ICMP reply, and this ICMP reply is used to check whether the destination device is responding or not. Okay, so test and reply, these two mechanisms are there. And the core responsibility of the ICMP protocol is to report the problem, not correct them. So the responsibility of the correction lies with the sender. So that is very important. That only this is a reporting mechanism, not the correction mechanism. And ICMP can send the messages only to the source, but not the intermediate routers, because this is because the IP datagram carries the addresses of the source and destination, but they do not have the routers, the address of the routers. Okay, we'll see the details in the next video.